Already have seen deviation. Deviation. Now we have to find out minimum deviation. This is what? Minimum deviation. Write down. We have to see minimum deviation. What is that? Minimum deviation. This is a practical concept. This is a practical concept, and we have to write in theory here. What is minimum deviation? Same diagram. No change in the diagram. Same diagram I have to see. Same diagram. You see? I have to see the same diagram. Same diagram I have to see. And this is what practical what thing here you have to see. Same diagram. If I'll draw, already have drawn this, so don't draw anything. So this is what A, this is what B, this is what C. It's a prism. This is the angle of prism here. Understand this? And incident ray is what? Like this, incident ray. And I have to draw normal here.
Sir, Pranam.
This is what the normal. Already have done this. This is the refracted ray. And again another normal here you have to draw. Again another normal here you have to draw. And here emergent ray. And this is the angle of incidence I. This is the angle of refraction R1. This is what R1. This is what E. And deviation is what? Deviation is like this. If you just produce backward, this is what the deviation, delta or D. Already have seen this. And its refractive index is mu1, its refractive index is mu2, and this is again mu1. So what is minimum deviation here? Try to understand this. In practical, what will happen? In practical, what will happen here? Hello? Hello? Practical application, what will happen? You are taking a prism, here, you are taking a prism at a normal ta, you are just what? Increasing the angle of incidence and see the deviation is how much. First I1, then I2, then I3, then I4, then I5. Go on increasing this angle of incidence and measure the deviation. What is the deviation here? Measure the deviated angle, deviation angle of deviation we measure karo. By increasing angle of incidence, go on measuring the deviation and draw the graph between what? I and D. If you draw the graph between I and D, ID curve, that is known as ID curve, that is what I and angle of incidence and deviation delta or D. If I draw this on increasing angle of deviation, on increasing angle of deviation, on increasing angle of incidence, deviation goes on decreasing. Clear? On increasing angle of incidence, the deviation goes on decreasing. Decreasing. Look here, the graph will be like this. On increasing angle of incidence, the deviation goes on decreasing. At a particular angle of incidence, deviation is minimum. On increasing angle of incidence, further the deviation goes on increasing. Understand this? जेमती तुम्हें एंगल ऑफ इंसिडेंस बढ़ाई बढ़ाई चलो the what angle of deviation goes on decreasing. You see, on increasing angle of incidence, deviation goes on decreasing. At a particular angle of incidence, deviation is minimum, and this is known as minimum deviation. And further increasing angle of incidence, the deviation goes on increasing. So this is the point of discussion, angle of minimum deviation. Angle of minimum deviation. So we are drawing angle of minimum deviation from the ID curve. From ID curve, minimum deviation. Write down, write down, write down ID curve of prism. Write down ID curve of prism. Write down ID curve of the prism. What is that ID curve? Let's see this. ID curve. Draw this ID curve. ID curve. ID curve for prism. What is the ID curve? What is that ID curve of the prism? Let's see this. What is ID curve? Means I have to take I and D. This is what I and D I have to take. This is a curve. This is a practical curve. And from practical, we are reading in theory. Practical curve, this one. This is what? D, deviation, delta, and this angle of incidence. And it is a freehand curve. Freehand curve means what? You see, on increasing angle of incidence, deviation goes on decreasing. At a particular angle of incidence, deviation is minimum. Deviation is minimum. Draw this. This is what the point of discussion. at minimum what? Minimum deviation, the angle of incidence is this much. So this is what? Minimum deviation del m or capital dm. Write down, draw the figure, graph draw karo. Excel law, have it completed this? Write down
Yes, sir.
characteristics of id curve. Write down characteristics of characteristics of id curve. Characteristics of id curve. Write down characteristics of id curve. Number 1, it is curve in nature. Number 1, it is curve in nature. It is curve in nature. Number 2, number 2, number 2, on increasing angle of incidence, on increasing angle of incidence, deviation goes on decreasing. On increasing angle of incidence, deviation goes on decreasing. Deviation goes on decreasing at a particular angle of incidence. Deviation is minimum. At a particular angle of incidence, deviation is minimum. At a particular angle of incidence, deviation is minimum, and this is known as minimum deviation. At a particular angle of incidence, deviation is minimum, and this is known as minimum deviation. This is known as minimum deviation. Minimum deviation. On further increasing angle of incidence, on further increasing angle of incidence, the deviation increases. The deviation increases. The deviation increases. Understand this? So what is minimum deviation? Write down minimum deviation. What is that? Minimum deviation. What is that? Minimum deviation. Write down. This is the minimum angle turned by the incident ray. This is the minimum angle turned by the incident ray to become emergent ray. This is the minimum angle turned by the incident ray to become emergent ray. This is the minimum angle turned by the incident ray to become emergent ray. So at minimum deviation, you can observe three important things. If you are getting your minimum deviation, suppose I am getting minimum deviation here, exactly here. I am getting minimum deviation here. So exactly a point, you can observe the following three important things. What are those? First is I is equally, always you will get I is equally at minimum deviation. These two angles are equal. If I is equally, then these two are parallel. N1 N2, the normal N1 and N2 are parallel with the base of the prism always. N1 N2 is parallel with the base of the prism. And if I is equal E here, I can say R1 is equal R2 and that is equal to A by 2. At minimum deviation, always will get three things, very important thing. Always will get three things. What are they? Write down. At minimum deviation, write down. At minimum deviation, following three observations can be made. At minimum deviation, following three observations can be made. Number one, I is equal E, always. Always will get at minimum deviation. I is equal E. Second is what? R1 is equal R2, that is equal to A by 2. So R1 is equal R2, that is equal to half of the refracting angle of the prism or angle of prism. Third thing is what? The refracted ray N1, N2 is parallel to the base of the prism always. N1, N2 is parallel to the base of the prism. These three things you can observe at minimum deviation. At minimum deviation, these three things you can observe. Very important. I is equally R1 equal to R2 equal to A by 2, and N1, N2 is parallel to the base of the prism BC. Any questions from this? Any question? We have to find out the relation between refractive index and minimum deviation of prism. Write down. Relation between this is always coming in the exam. Relation between refractive index mu and minimum deviation of the prism. Relation between refractive index of the prism and minimum deviation. What is that relation? Let's see this. So same diagram, again same diagram we have to draw. Same diagram. Clear? Same diagram. This is air. If you are taking this air, this can be treated as 1. If this can be treated as air, this can be taken as 1. And mu is the refractive index of the prism. Instead of mu2, I can put mu. Write down. Applying laws of refraction or applying Snell's law, write down. Applying Snell's law for the refraction of light, applying Snell's law for the refraction of light through face AB, what will get? How much will get? Huh? What is that? Sin I by sin R1 is equal mu 1 to 2. This is what Snell's law. Snell's law is what? Sin I by sin R1 is equal mu 1 to 2. Light is traveling from 2 to 1, 1 to 2, 2 with respect to 1, or mu. Mu is the refractive index of the prism. Write down. Applying Snell's law, refraction through the face AB. What? AB, what will get? That sin I by sin R1 is equal mu 1 to or mu. Write down. Where mu is the refractive index of the prism. Where mu is the refractive index of the prism. Refractive index of the prism. Write down. At minimum deviation, write down. At minimum deviation, I is equal E, R1 is equal R2 is equal A by 2, and what is that? Deviation delta is equal del M. Deviation delta is equal del M. Therefore, we are having the formula. What is the formula? What is the formula? Relation between deviation and angle of prism. What is the formula? I plus E is equal A plus delta. This is the formula. This is the formula na. So I plus E. I is E same as I. So I plus I is equal A plus del M. Del is equal del M. So 2I is equal A plus del M. Now my I is equal A plus del M by 2. Now I is equal A plus del M by 2. I is equal A plus del M by 2. Understand this? So what is that I? I is equal A plus del M by 2. Is it clear? A plus del M by 2. Is it clear? Any doubt up to this? Any doubt? Kara bujhibar achi? Any doubt? No doubts are there. Now, therefore, what is that? Mu is equal sin I by sin R1. So my mu is equal sin I. I is what? A plus del M by 2. R1 is equal sin A by 2. This is what the relation between refractive index and minimum deviation. Very, very important. This is what the relation. This is what 5 marks will look out. Deviation for small angle of incidence. Write down. Deviation for small angle of incidence. Deviation for small angle of incidence. small angle of incidence. Again, I have to draw the same diagram. Clear? Again, I have to draw the same diagram. This is what the prism here, same diagram. Prism, incident ray, normal, and refracted ray. Here again normal, another normal. This point is O, and this is emergent ray. This is I, clear, emergent ray. And this is what angle of prism, AB, AB, C. This is what angle of prism, A. Now this is what I, this is what R1, this is what R2, this is what E. Understand this? And deviation, you know already, this is what deviation, delta. Now you see this is what mu1, and this is what mu2, and this is what mu1. Now all the angles are small, very small. Write down. Again same diagram you have to draw. So leave space for that. Same diagram. That what I have drawn in first do draw complete. Same diagram you have to draw. Leave space. Write down. Applying Snell's law. Write down. Applying Snell's law for the refraction of light. Applying Snell's law for the refraction of light through phase AB. Applying Snell's law for the refraction of light through phase AB, mu 1 to 2 is equal sin I by sin R1. Mu 1 to 2 is same as mu. Mu 1 to 2 is same as mu. 2 with respect to 1 is mu. This implies mu is equal sin I by sin R1, where mu is the refractive index of the prism. 1 to 2 is same as mu. Mu is the refractive index of the prism. Mu is the refractive index of the prism. Right on. As the angle of incidence and refraction are very small, as the angle of incidence and refracted angles are very small, therefore sin I is nearly equal to I, and sin R1 is nearly equal to R1. So what will get? Therefore mu is equal I by R1, or I is equal mu R1. So my I is equal mu R1. I is equal mu R1. Write down. Similarly, applying Snell's law, for the refraction of light through phase AC, similarly applying Snell's law for the refraction of light through phase AC, what is that? Mu 2 to 1, because light is traveling from second medium to first medium. So what will happen? 2 to 1, or 1 with respect to 2. Is your sine, angle of incidence is what? R2 divided by angle of refraction is E. So I can write this one as mu 2 is your mu 1 to 2. Mu 2 1 is 1 by mu 1 to 2, 2 with respect to 1, reciprocal. This is what? Sin R2 by sin E, or 1 by mu 1 to 2 means 1 by mu. This is what? Sin R2 by sin E. Write down. Mu 2 1 is 1 by mu 1 to 2. R2 and E are very small. Write down. As R2 and E are very small, therefore 1 by mu is nearly equal to R2 by E. So E is equal mu R2. Therefore I can write here what? I plus E is equal delta plus A. My I is how much? My I is mu R1. Mu R1 plus mu R2 is equal delta plus A. If you take out mu common, R1 plus R2 is equal delta plus A. R1 plus R2 is what? A. We know R1 plus R2 is A. A is the angle of prism. So here delta will be mu A minus A. Now you can take a common, mu minus 1 into a. This is the expression for small angle of incidence. Means 1 degree, 2 degree, 0.5 degree, like this. For large angle, this cannot be approved. Large angle pi, this is not approved. This is approved for small angle. This is approved for small angle. Write down dispersion. What is dispersion? Write down dispersion. What is dispersion? D-I-A, dispersion. P-E-R-S-S-I-1, dispersion. Clear? Dispersion. P-E-R, dispersion. What is dispersion? What is dispersion? In chemistry you read? Dispersion. What is dispersion? Dispersion is what? Splitting white light into its constituent color is known as dispersion. Understand this? Write down. The splitting of white light into its constituent colors. Splitting of white light into its constituent colors is known as dispersion. Splitting of white light into its constituent colors is known as dispersion. When white light travels in prism, लिख लगा dispersion. So you see, when white light is traveling in prism, what will happen? Then various speed of various color of light in prism is different. So first what will happen? First what will happen? Red light first you are getting, all you'll get 7 color. Vibgor, Vibgor, Vibgor color you'll get. Vibgor color you'll get. Understand this? What are Vibgor color? 7 colors you'll get. 7 color of light you'll get. This is what? Violet. This is what we are getting. Violet color. This is what? Violet to red. Violet to red. Violet bend most, red bends least. Understand this? If you'll see the deviation here, this is what? Deviation of red light, and this is what? Deviation of violet light. All those 5 colors you'll get in between. VIB, GYOR. Vibgyor color. Vibgyor is what? Another ray you are going to get here. You see another ray. This is what? Like this you are going to get. BIB, blue. This is what? Blue. BI, what is that? BG, green. Green color you will get. Green color you will get. Green. BIBGY, yellow. Yellow color we are going to get. VIBGYO. O is the orange color. You're going to get orange color. Understand this? You're going to get orange color. VIBGYOR. Look here. BIB. This is what? BIBGYOR. Vibgyor. This is the splitting of white light into its constituent color. Is known as dispersion. This is what? Dispersion. Or you can write dispersion like this also, no problem. If you are drawing the prism, draw this figure. Or simply you can draw like this, no problem. This is what? Red, orange, yellow, what? Green, blue, violet. Blue, indigo, violet. Like this also you can draw, no problem. Draw the figure. Figure draw karo. This is what? Dispersion. Clear? Now, cause of dispersion or Cauchy's formula. Cause of dispersion, write down, or Cauchy's formula. Write down cause of dispersion. What is the cause of dispersion or Cauchy's formula? CAUCHY, Cauchy's formula. What is cause of dispersion? Let's see this. Why this deviation occurs? Write down cause of dispersion or Cauchy's formula. According to this formula, the relation between refractive index and wavelength of light is given by, according to this formula, the relation between refractive index and wavelength of light is given by mu is equal a plus b by lambda and so on. Lambda square, lambda 4, like this. Lambda is very small, very large, so lambda square, lambda 4 can be neglected in denominator. So mu is equal a plus b by lambda and so on, where a and b are constants. Write down, where a and b are constants, where a and b are constants. So from this relation, we can conclude that on increasing wavelength, refractive index decreases. Do you follow this or not? If wavelength is increasing, refractive index is what? Decreasing, and vice versa. Understand this? So whose wavelength is more? Whose wavelength is more? Red light wavelength is more. Therefore, the refractive index of red light is less. Refractive index of red light is less. Violet wavelength is what? Less. Therefore, refractive index is more. So write down, as red light refractive in as red light wavelength is greater than violet wavelength, therefore refractive index of red light is less than refractive index of violet light. If refractive index is what less here, what will happen about the deviation and refractive index? Mu is equal, deviation delta is equal mu minus 1 into a. Already I have derived this. So you see that if refractive index is more, deviation is more. If more is a refractive index, more is a deviation. Understand this or not? So whose deviation will be more? Therefore, del R is less than del V. Refractive index of violet is more than red light. Therefore, deviation of violet light is greater than deviation of red light. Deviation of violet light is greater than deviation of red light. Understand this? The deviation of violet light is greater than deviation of red light. Is it clear? Are you understand this? Are you clear about this?
Again.
Yes, sir.
Is all about your prism. This much is there in the course. Clear?